Dear students, how are you? Hope all of you are maintaining all the rules and regulations in this pandemic situation, because as we know that second wave is coming, so be careful. This is Rita Rani Guho, lecturer, Department of Chemistry, Milestone College. Today I am going to discuss two creative questions of chapter 6. The name of this chapter is Concept of Mole and Chemical Calculation. Question number 1. 8 gram magnesium oxide and 11 gram carbon dioxide are mixed up to produce 21 gram magnesium carbonate. But at the end of the reaction, expected amount of product was not obtained. Question A. What is molarity? Actually, molarity is the unit of concentration. That means the amount of number of mole of solute dissolved in 1 liter solution is known as molarity. That means molarity is expressed by capital M, and M is equals to N by V. The unit of N is mole and the unit of volume is liter. That means molarity is equals to mole per liter. Now, question number B. Determine the percent composition of HCl. You know that if you want to determine the percent composition, at first you have to determine the molecular mass of the compound. Here, molecular mass of HCl equals to 36.5. Therefore, percent composition of hydrogen is equals to mass of hydrogen. Mass of hydrogen is 1. 1 divided by mass of the molecule into 100 is equals to 2.73%. Now, percent composition of chlorine is equals to mass of chlorine is 35.5 divided by 36.5 into 100 is equals to 97%. You can check yourself your math is correct or not. If you find that the total of percentage composition of all the elements are 100%, that time you can understand that yes, your math is correct. Here 97% plus 2.73% is equals to 99.73%. That means 100%. So that your math is correct. Now, come to question C. How many moles of carbon dioxide reacted at the reaction of the stem? Explain mathematically. For this math, you have to determine the molecular mass of carbon. Now, question C. How many moles of carbon dioxide reacted at the reaction of the stem? Explain mathematically. So, to solve this math, at first you have to determine the molecular mass of carbon dioxide. Molecular mass of carbon dioxide is equals to this. That means 44. So, can I say that 44 gram carbon dioxide is equals to 1 mole? 44 gram carbon dioxide is equals to 1 mole. Therefore, 1 gram carbon dioxide is equals to 1 by 44 mole. Therefore, 11 gram carbon dioxide is equals to 11 by 44 mole is equals to 0.25 mole. That means the mole number of carbon dioxide that took part in this reaction is 0.25 mole. Is that clear to you? Okay. C is finished. Now question number D. Analyze mathematically the reason of not producing the expected amount of product. At first you have to show the reaction. Reaction is magnesium oxide plus carbon dioxide is equals to magnesium carbonate. Here mass of magnesium oxide 40, 44 and this one is 84. So for producing 84 gram magnesium carbonate, how much magnesium oxide is needed? 40 gram. 40 gram magnesium oxide is needed. Therefore, for producing 1 gram magnesium carbonate, 40 divided by 84 gram magnesium oxide is needed. Therefore, for producing 21 gram, you know that our target is 21 gram magnesium carbonate, how much? 40 into 21 divided by 84 gram magnesium oxide is needed. That means 10 gram. 10 gram magnesium oxide is needed and given amount what? 8 gram. So what is the shortage? We need 10 gram but given amount 8 gram. Therefore shortage of magnesium oxide is equals to 10 minus 8 gram is equals to 2 gram. Now come to the amount of carbon dioxide. Let's know the amount. For producing 84 gram magnesium carbonate, 44 gram carbon dioxide is needed. For producing 1 gram magnesium carbonate, how much? 44 divided by 84 gram carbon dioxide is needed. Therefore, for producing 21 gram magnesium carbonate, 44 into 21 divided by 84 gram carbon dioxide is needed. Is equals to 11 gram. How much carbon dioxide is given? 11 gram. So sufficient amount has been provided, carbon dioxide, and there is a shortage of magnesium oxide of 2 gram. For the shortage of 2 gram magnesium oxide, expected amount of product was not obtained. So how will you draw the conclusion of this? For the shortage of (2 gram magnesium oxide), expected amount of product was not obtained. Is that clear to you, dear learners? Now come to the question number 2. Here stem is 39 gram calcium oxide is obtained by heating 80 gram of limestone. Question A. What is limiting reactant? The reactant which is fully used in a chemical reaction is known as limiting reactant. That means which reactant doesn't remain in chemical reaction or in reaction medium is known as limiting reactant. Question number B. What is the number of molecule in 5 mole sodium carbonate? So, can we write that number of molecule in 1 mole sodium carbonate is equals to 6.02 into 10 to the power 23 as per Avogadro's law. Therefore, number of molecules in 5 mole sodium carbonate is equals to 6.02 into 10 to the power 23 into 5 is equals to 3.01 into 10 to the power 24. That means in 5 mole sodium carbonate there is this number of molecules. Is that clear? Okay. B done. Now come to C. How much limestone is needed to produce 25 ml 0.5 molar solution? You know that the chemical name of limestone is calcium carbonate. So, we have to apply a formula for this problem. Can you say which formula should be used? The formula is, you know, W is equals to SDM divided by 1000. Here S is equals to concentration. Here what is the concentration? 0.5 molar. V is equals to volume. Volume is equals to how much? 250 ml. Then M is equals to molecular mass of calcium carbonate. Molecular mass of calcium carbonate is equals to what? Is equals to 100. Is that clear? Okay. Now put the values. S is equals to 0.5 into 250 into 100 divided by 1000 is equals to 12.5 gram. That means 12.5 gram calcium carbonate is needed to produce 250 ml 0.5 molar solution of limestone. And students, now question number D. Analyze the percent of product of the produced calcium oxide mathematically. You know the formula of determining percent of product is equals to the amount of product which has been obtained practically divided by the amount of product which was supposed to obtain theoretically into 100. So at first we have to write the reaction. Calcium carbonate is heated. After being heated, calcium carbonate is producing calcium oxide plus carbon dioxide. Here, molecular mass of calcium oxide is 100. Molecular mass of calcium carbonate is 100. Molecular mass of calcium oxide is 40 plus 16 is equals to 56 and carbon dioxide is 44. Now, we can say that from 100 gram calcium carbonate, 56 gram calcium oxide can be obtained. Therefore, from 1 gram calcium carbonate, 56 divided by 100 gram calcium oxide can be obtained. Therefore, from 80 gram, at the stem there is given 80 gram limestone. Therefore, 80 gram limestone, 56 into 80 divided by 100 gram calcium oxide is equals to 44.8 gram. That means theoretically we are supposed to get 44.8 gram calcium oxide from 80 gram calcium carbonate. But practically we found 39 gram. Therefore, percent of product is equals to what is obtained practically 39 gram. 39 divided by what was supposed to get 44.8 gram into 100 is equals to 87.05%. This is the percent of product of calcium oxide. So, today up to this. See you at the next class. Thank you.